Ladies and gentlemen, good morning. So Algorand's solution to the blockchain interoperability. So let me start by thanking the organizers for inviting me. I think I like chess and I'd like to be back. Let me continue with actually congratulating the organizers to have the guts in such a global situation to organize yet one more time such a civilized encounter. We needed more of these than less. And finally onward to all of us with science, pandemic or not, life continues and we want to make it better. Great. So here is the agenda for today. A quick recap about Algorand. Then let's discuss interoperability, what our expectations are from it. And then we distinguish two kinds of interoperability, which we call core chains and decentralized token bridge. And I will guide through it. All right, Algorand. Well, first of all, everybody knows what the blockchain is, a decentralized database, readable by anyone, writable by anyone, inalterable by anyone. The potential is immense because who does not like a database which is inalterable? Who does not like transparency? Who does not like generating trust among people who barely know each other? The applications are unlimited. But what has challenged the blockchain world from the very beginning is the big gap between our aspirations and the technology. And it is good that there is a gap because we want to keep our aspiration higher and higher, but at some point in time, unless we sustain it with real technology, they remain a pie in the sky. So, as a proof that somehow the aspiration were disconnected from the technology, I just want to quickly recall the famous Buterin trilemma, right? That in a blockchain, you cannot have simultaneously decentralization, security, and scalability. If this were true, we're really terrible. And is not acceptable because do you want to get rid of security? Are you kidding? Do you want to get rid of decentralization? Why do you have a blockchain? Do you want to get rid of scalability? What is the blockchain going to do? Helping friends and family? The trilemma is not acceptable and fortunately is false. So in fact, Algorand managed to be decentralized, secure and scalable at the same time. And by the way, it has also some good properties, such as full transaction finality. In other words, every block that appears on Algorand remains on the chain, no matter what. So if you are paid and your payment appears in the latest block added to the chain, ship the good because you know in Algorand that that block is going to be there forever. There are no forks and disappearance of blocks that you have to worry about. Another good thing is layer one smart contracts. So these are smart contracts that actually are not done at layer two. They are not fragile. They are not somehow expensive. They are not slow. They are done every 5 seconds like an Algorand block. At the same layer, they handle all consensus. So they are as secure and as fast as an ordinary payments. And then we have our own smart contract that finally a totally different design. And by the way, we have all kinds of other properties. So let me just here recall these layer one smart contracts quickly. And what are they? First of all, they are smart contracts. And they are handled at the consensus level without slowing down the block generation and with the same efficiency and security of ordinary payments. Let me give you an example. Atomic swaps, most useful tool perhaps in trade. You have an asset that I want, I have an asset that you want, and now you want to swap them. Now, the point is that in a blockchain like Algorand, I can give my asset to you in a few seconds, but then I'm going to say, please, 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 give me your asset. So nobody wants to go first. How do we solve this problem in the real world? How about a trusted mediator? Well, no thanks. Why? Because it's costly and it's also rare. You live in Thailand, say, I live in Boston, Massachusetts. What are the chances that we know a third party that we both know and trust? How about traditional smart contracts? Well, you know, they are slow, they are costly, and they are fragile. No day passes by that, you know, somebody loses millions of dollars on a layer 2 smart contract going rogue. Well, how about hash time locks? Well, they are slow, and they are also vulnerable to DOS. Never mind why, but it is a fact. So then what do we do in Algorand? We swap in a single transaction, okay? So in other words, I post something on the blockchain knowing that if and only if you do the same, which I don't know if you're going to do, but if you do, bingo, the items are swapped. So what is good about a single transaction is that there is no cheating, right? Because it's not that I assign you first and then I depend on you. It's a single transaction, I cannot cheat. You get what you want if and only if I get. Is no error because it's done at the layer 1 at this, and it is really a form of ideal trade. That's what the trader wanted to be. And by the way, these layers 1 smart contracts do encompasses only atomic swaps? Not at all. You can tokenize an entire building in layer 1 without having a layer 2 smart contracts. You can collateralize on, you can run auction, etc., etc., etc. There is, as it turns out to be, a lot of room for layer 1 smart contracts to grow. All right. Enough about blockchains in general and Algorand. Let's focus now on interoperability. Okay. No chain is an island. What does it mean? That it is always true that the world outside is larger than the world is inside. Who has said it? I don't know, but so therefore I attribute it to me. So that is why no matter how good and rich your ecosystem can be, the world at large is a bigger and better place. And if you don't do it, when you are the first prisoner of a blockchain that traps you from the outside that there is going to be. Not a good place to be. All right. Then you want to interoperate. Among whom? Well, chains that runs the same consensus protocols and chains that runs different consensus protocols. The first type of interaction, we call it co-chains, and the other ones, a tool allows such interaction, we call it the decentralized token bridge. Let me drive through it. So let me tell you about Algorand co-chains. What is a co-chain? First of all, it's an independent chain, okay? So you run your own consensus. Algorand verifiers do not interfere with it at all. You are in charge of your own destiny. You are a private chain, that means that the world outside cannot see your transaction at all. Perfect privacy. But inside, you need a blockchain, you need a consensus mechanism. What consensus do you run? Algorand. That makes you a co-chain. And by the way, why do you want to run Algorand? Oh, for 3 great reasons. The first one is, as we said, is scalable, secure, and distributed. So I think it's a good idea. If you want to look for a good consensus, you don't look farther than that. The second one is that you enjoy these layer 1 smart contracts and these auctions and a layer 1, and that is actually good on its own. Don't you want your own members of your own ecosystem, of your own blockchain, to have a large suite of smart contracts with the same ease and security of ordinary payments? Of course you do. And the third thing is interoperability. And interoperability between whom and whom. The first form of interoperability is between a co-chain that you see there in blue, a blue co-chain, and the main chain in black. And so you may want to transfer a blue asset, an asset that you own, to the main chain. Why do you want to do that? Oh, simple, because that day there is going to be an auction. And when you put an asset in an auction with a lot of bidders, a lot of participants, the price you get is much higher as the number of bidders grow. So if you want to put it in a public permissionless Algorand where the entire world can bid, you are better off to sell your asset there. Okay, you sold it, and now what? You repatriate the assets in your own co-chain. And I want to tell you that highway, 4-lane, 8-lane highway in each direction, they are very, very fast to transfer your asset to the main chain. And once you sold it, very fast to transfer the money back. Excellent. Now, there is going to be another type of interaction in which is somehow co-chain to co-chain, but there is still a main chain in the middle. There is a blue chain with asset blue A, a red chain with asset blue B. And what do they want to do? First of all, they transfer the asset to the main chain, and they actually choose to transfer to some specific public key that they choose. This public key has random and use it only once to give you some privacy. So that you say, this asset I want to be on in the Algorand main chain to public key blue PK. The other asset, red B, to public key red PK that you just made. Each one of us makes these choices ad hoc. And now, because these are super highway, in a few seconds, our assets are now associated to the public key that you control, red PK, and the public key that I control, blue PK, and there they are. And now, by means of our legendary atomic swaps, we swap them. Okay, that's a few seconds in layer one. And then what do? We repatriate the assets by giving to the same public key that we control in our respective blockchain. So you transfer to the main chain, you swap them there, and you repatriate the new goods that you have acquired. Meanwhile, the main chain has actually a good thing. It records that where the asset blue B is and where the asset A is. So if somehow I go nuts in my blue chain and I try to transfer A again, the main chain says, well, I know, Silvio, dear Silvio, that now this asset A now is red, it belongs to the red chain. You are not allowed, you cannot transfer, you cannot sell it, you cannot, it's not yours anymore. Very good. So, okay, so we have here an ecosystem, people who run Algorand inside, and but they are separate chains, and they can, of course, have the best of breed consensus protocol inside, and they can operate very quickly with through the Algorand main chain with everybody else. And I claim that they can do it in a decentralized way. Why is this claim plausible and believable? Well, ultimately, because chains that use the same consensus protocol can interpret each other's block. Because the syntax is the same. Once you specify who the verifiers are, I know how a block of yours look like, and you know how a block of mine looks like, because it's the same structure of the blocks that the main Algorand chain uses. Excellent. Okay, I got it. In other words, this notion of a co-chain is like main chain becomes a hub for all the private co-chains that are around. All of them independent, but you somehow interconnected, is a hub. Wait a second. The hub here it is in this picture, is connected to everything, very big pipes connecting to everything else. And you say, is this a new idea? A new idea? Of course not. There is a lot of people who want to do the same thing. And somehow Polkadot is one thing, Cosmos is another thing, Algorand wants to do a thing. If you really want to join the crowd and having implemented this hub idea, you better take a taxi because the line is long and it's going to take some time to get there. But let me ask, are all hubs equal? And let me give you a hint. No. A hub is only as good as the infrastructure that it offers. So the notion that you can go and parachute assets to a common center, that's okay, that is the same. But then what do you find in the center, that matters. So let me give you an example about airline hubs that everybody knows. Assume that you have a hub in which you have actually mechanics to serve your planes. You have hangars where your planes are going to be worked on. You have hotels when your crew misses a plane that needs to rest. You have hotel, restaurants, the whole bunch of infrastructure. And in another hub, you say, well, you get the free ice cream. Well, let me tell you, it's pretty clear that you choose this hub. So remember, the idea is the same, but somehow it is the hub that gives the value to this hub idea. Okay, so we believe that the hub is where the tech is. And we have a lot of tech: verifiable random functional, layer 1 smart console, cryptographic sortition, quantum resiliency, player replaceability, vault, random access, etc., 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 that we hope we find very comfortable living in the hub or interacting whenever you want in this main center hub. Okay, now decentralized token bridge. We have understood this co-chain interactions, interoperability between chains that runs the same consensus protocol as Algorand main chain. What is the centralized token bridge? Well, first of all, now we want to somehow interoperate with public chain with different consensus. How different can be the consensus mechanism in public chain? Very different. In fact, scarily different. So, proof of work. Here is the idea of the main consensus. The first one to solve a very hard cryptographic riddle chooses the next block on behalf of all of us. Delegated proof of stake. Oh, choose 21 people. Hopefully they'll be honest, and they will choose the next block on behalf of all of us. Well, is it decentralized? I don't know that, but never mind. Bonded proof of stake. Delegates who put money in the table, hostage, and they are the ones who choose the block. And then now you have a pure proof of stake that Algorand chooses, in which a somehow token is randomly selected by magic among all tokens. This token must belong to some public key. This public key by magic becomes known to all users. This public key must belong to somebody, and that somebody proposes and propagates a new block. After he or she has done that, 1,000 tokens are randomly selected by magic among all possible tokens in the ecosystem. Their key becomes known to all users, and their users agree, their owners agree on the block proposed by the first users. All right. So what is the problem? The problem that helps us making the plausibility argument that this is going to work in a decentralized manner, in the case of co-chain, no longer works here, because it's no longer true with so much diversity among consensus protocol that we can interpret and recognize and verify a block of each other. And then what are we going to do? Oh, the first thing we are going to think is to say, oh, by the way, here is a block. It can be as simple as having, something that, what is a block? Something that hash gives you a bunch of zeros. And here is on the other extreme, you put something, say, oh, here is a proof that I won a lottery that allows me to propose a block, etc., etc., etc. That's a kind of idea. So what to do? The first temptation is centralization, because when we don't know what to do, we think centralized. So we imagine we have here a central party who is going to help us interoperate. And the central party proudly declares, I am trusted by you all. So you say. And assume now, let's make it concrete. The central party tells you, an asset blue A has been transferred from the blue chain from the red chain. Trust me that is no longer as this assets in your blue chain. Trust me that is nowhere else except in your red chain, and you're willing to buy, ready to buy it, and bids starts $100 million. Well, what are you going to do? Before I start the bidding on $100 million item, do I know that the asset no longer exists anywhere? Unfortunately, remember that all this is very opaque, whatever happens in the blue chain to me. Is a kind of a dark cloud that I can't see inside things at all. So I say, well, I'm hesitant to participate into the auction. What? Do you dare to distrust me? As a matter of fact, yes. You centralized swine, I distrust you. Next idea. Oh, very great idea. Now we have not one party, but 7 parties. And if a majority of them somehow work for, say, out of the 7 are honest, now this reporting that an item really has been deleted on one chain and transferred, maybe I should use it. And by the way, these parties, they seem to be midgets. They're not midgets. They are the 7 dwarfs, right? Dopey, Sleepy, Grumpy, and the rest. And why are the 7 dwarfs? Because remember that in a blockchain that really works, okay, it should secure trillions of dollars in assets. And there are going to be some really big players, some very big asset transfer back and forth. And who are these 7 midgets who want to help us? And the fact that they post some money that they are at risk of losing if they say the truth means nothing, because when the money is so high, the ability to bribe people and let them lose the piggy bank, the piggy bank doesn't give you any assurance of honesty here. So what is our philosophy? Our philosophy is very simple. If somebody wants to transfer an asset from a blue chain to the red chain, 2 things are going to be true. First, that somebody already trusts the blue chain because he has kept her asset here so far. And B, he must trust the red chain because he wants to transfer there. And our philosophy is that this party should not need to trust anybody else. Period. Not 1 midget, not 3, not 5, not 7. So what do we want is a decentralized token bridge. So let me tell you what is the tech required for doing this. At the end, we need 2 main tools. One, we need the blue chain to have smart contracts and the red chain to have smart contracts. And by the way, if the blue chain does not have any smart contract, or, it doesn't even have interoperability inside, so the notion that we should demand that it interoperates with the outside is a little bit perhaps too much. And the second tool is compact certificate. And what are these compact certificates? These are reciprocally parsable, easy to interpret representation of the will of the entire blockchain. Don't trust the midget to tell you what the blue blockchain has been done, has been doing, or the red chain has just done. You want the word of the entire blockchain. Okay, so let me tell you a little bit on this more about compact chain certificates. Compact chain certificate, we are going to do some magic. They start easy. Somehow you started taking a commitment to all balance sheet of the blockchain. Public key, number of tokens each blockchain has. And as you can imagine, this commitment is very, very small. Here it is. Then, because we want to represent the will of the entire chain, we collect the signature of 80% of the stake of the chain. The commitment tells you where the stake is. And now that you know, we just sign. 80% of the stake should sign. Well, guess what? Now the commitment was small, but collecting so many signatures now becomes great. So what we do then in the last phase is that we do a convincing signature reduction by shrinking this number of so many signatures to something as few as 64 signatures, okay? So by magic is that even though the signatures are only 64, by magic, you know that they represent, without error, the will of the entire blockchain. Okay, that is compact chain certificates are, and that's how they are implemented. So implemented is in 2 phases. The first phase, Algorand, we shall implement individual solutions based on fancy algebraic construction. And our next implementation is going to be fancy use of what? Of hash function only. And why hash functions? Because 2 reasons. First of all, they have an added bonus that they are quantum resilient. And second, to tell you the truth, is that every blockchain understands hash function because every chain hashes the previous block. All right. So stay tuned. We are going to bring a token bridge to you in the next few months. We are already started, coding things up. And in finishing, let me tell you what my take is. My take is that blockchain are sophisticated goals. And sophisticated goals require sophisticated technology. And now about technology. I really believe technology is quintessentially humans. Ever since we came down from the trees to produce our first tool, we became more human. And actually technology is going to be really crucial to realize our human aspirations. Let me tell you, our world is becoming increasingly complex. And we need more and not less technology to solve this complexity and keep us alive even as a species. So technology has been our past, our present, and will be our future. So long live technology and a good day to all.